Holy crap, Mr. JMC, I hope you've been good, dude. It's good to hear from you. And hello, everyone. Hey, Vasan. I am. I am. I feel kind of like pre-sick. I hope I'm wrong. But other than that, I'm doing good. Yeah, I hope like work's going good and all that stuff for you. Oh shoot, I meant to bring up something. I was on the starting student screen and then I forgot. We need to go to based Paul. And I need him to teach me Lagrange multipliers for like the bajillionth time. I know, it's just been like going around. Yeah, no, it's just like a weird feeling in my head. It's like not quite a headache, but like it feels like it could like turn into one. Okay. So this is for my math biology class. We're asking about heterozygotes, which are zygotes with like two different alleles. Like you have the allele for blue eyes and the allele for brown eyes or whatever, and like whichever one dominates, but we don't care about that part. It's not a sore throat feeling. I think you'll be good. Well, okay. Now I'm thinking about having a sore throat, and then my throat starts to feel a little bit sore. That always happens with me. I think my throat's been okay though. I don't know. For some with sore throats, if I start thinking about it, I start to feel like I have one. Like the idea gets put in my head. I just need to forget about it again though. But yeah, I did just go and pick up some like apples too, just so hopefully, I don't know, prevent anything before it happens. 3 streak, thank you, thank you. Oh man, there's 2 different ways that we could do this. Hey, Naman. So I did most of this problem off stream. It's a little bit hard to like even describe what the background for this problem is, but basically, it's possible to count like if you know certain things, you can count like the frequency of certain alleles in the population to figure out what percentage of the population have 2 different alleles. Got any experience with solving mechanical wave equation problems? No, I don't. I'm sorry. And so it's pretty easy to do if the particular gene only has 2 alleles, but in general, genes don't usually have 2. They can have 3 or more. And so I did it for 3, and then we have to do it for an arbitrary number of alleles, and that's where things get kind of tricky. Because already at 3 alleles, we have a multivariable optimization problem. And doing variable optimization for an arbitrary number of variables is a little bit difficult, but it actually it can be done. Are we doing more math about genes? Yeah, at least for now. I'm hoping this one won't take up that much time, and then I'll move on to a different class's homework. But I might get stuck on something. Hope you're doing well, Dora. Let's see. For early, I slept for a few hours. I woke up by my neighbor's music. Oh, that sounds terrible. You having tea now? I hope you enjoy. Yeah, I maybe have seen something like that before, Naman, but I haven't really solved problems with it. I wouldn't really know what I'm doing. So basically, this is the start of my work for n alleles, and you have p sub n, or sorry, you have n many variables here. Test the real robot again today. It worked so good for the first time. Hell yeah, that's huge. And then my idea to solve this was to, these are all like proportions, and they have to add up to 1, so we can eliminate one of the variables, and I just chose p sub n to eliminate. So we can reduce one of the dimensions, and if you are careful and follow through on the patterns with everything, you can get something that looks like this. Actually, this is slightly wrong. I fixed it in my LaTeX, and I didn't fix it in my work, or like my Scratch work here, because I actually wasn't careful enough with this pattern. 2p2p3 minus ... Ah. Hey, Q. Minus 2p2pn minus 1 minus 2p. I need even more room, bro. N minus 2, n minus 1. There we go. That's a better representation of the pattern. Boz? Wait, is this a coincidence? That you and Julian are here at the same time? Love is for the lucky and the brave. I guess so. That's a decent fortune. Most of those fortunes are not that good. That's an okay one though. The lucky and the brave. I don't know. I feel like there's something missing, maybe, but I could go along with that. Yeah, so I end up with this n minus 1 dimensional equation, and I want to optimize it. So I take n minus 1 many partial derivatives and set them all equal to 0. And that's that thing there. And then I set up a system of equations to solve it. And you might not think this could be solved, but it actually can. I was really struggling with it for a while though, because you have to be careful with the patterns. But basically, if n equals 2, I expect 1/2 for the proportion. If n equals 3, I expect 1/3 for the proportion. And so for arbitrary n, I think it's going to be 1 over n. When yo algebra linear, indeed syntax. This is some serious linear algebra-ing when you're solving an arbitrary number of equations. And so I was really just worrying about getting like the final variable here, so that comes out to be 1 over n. That's gonna basically assure me that all the others are gonna be 1 over n as well. And so what you find is that this entry here starts as 2, and then as you do row operations to try and get zeros on that lower triangle, you're going to end up subtracting off 2 minus a half, minus a sixth, minus a 12th, and this turns out to be a series of things that you're subtracting off. And luckily, it's a telescoping series, so you can actually find a closed form for its sum. Turns out to be n minus 2 over n minus 1. And so I can get the final row is 2 minus n over 2, or 2 minus n minus 2 over n minus 1 times p n minus 1 equals 1 minus n minus 2 over n minus 1. Been reading my linear algebra book, my linear algebra 2 book, and it no longer has anything to do with vectors or matrices. That is advanced linear algebra for you. It's a good place to be because that's where you're learning some really deep stuff, but it is weird. And I haven't really learned it for myself either. I've run into it naturally when learning other types of math, but I haven't studied that type of advanced linear algebra specifically, and I would like to one day. Yeah, and like there's other weird things, like vectors are no longer lists of numbers, they're just arbitrary objects. So yeah, and then if you turn this last row back into an equation, you get that, and you can solve that equation to get p sub n minus 1 is 1 over n. And when I got that last night, I was really happy because this was a really long calculation. Vectors, it's an element of a vector space. Cool, thanks, bro. Exactly. Tenses are objects that transform like a tensor. True, Tertar. But yeah, so like just in my scientific computing class, we've been talking about the Fourier transform, and one second. That's the most recent place where I've run into like advanced linear algebra. So yeah, linear vector spaces. V is a linear vector space if it is closed under addition and if it is closed under scalar multiplication. And then the example that we were given of a vector space is C of omega, which is the space of continuous functions on some set omega that is a subset of Rd. It's like d-dimensional real numbers. And so the sum of two continuous functions is another continuous function, and the scalar multiple of a continuous function is a continuous function, so it works. You can also have L2 of omega, which is the space of square integrable functions and stuff like that. Also, like, differential equations has, like, linear operators. I mean, linear operators exist outside of differential equations, too, but... yeah. Yeah, that would be closed under addition, specifically. You could also be closed under some other operation, too. The transition to infinite dimensional vector space is really satisfying. All the summations are just integrals. Integral transformations are just matrix multiplication. Yeah, Territar, that's kind of crazy. Like, I haven't gotten that deep yet, but like... We have seen infinite dimensional vector spaces because of these like basis functions that come up for like Fourier transforms and stuff, or Fourier series, maybe, I don't know, something like that. Okay, but yeah, linear algebra is cool, and it's really helpful. Is the moral of the story. Okay, so I got my almost my holy grail, which is 1 over n. The issue is that and so all the other points are also going to be 1 over n. I didn't bother showing that because this problem was tedious enough already. And I didn't even do it right, so the goal of today is to redo it. I mean, I think I did it right, but not this next part is what's not probably right. I found that 1 over n, 1 over n, ooh, dot dot dot, 1 over n is a critical point of this n minus 1 dimensional function. And so to show that it is a maximum, I got all the second derivatives using this, like, these first derivatives. And they all turn into constants, all the second derivatives, which is helpful. And you end up with a Hessian matrix that looks like this. And so I never had to prove something is a maximum in more than 3 dimensions. And the condition is that it is a maximum if this thing is negative definite, as opposed to positive definite would be a minimum. And that's what I got kind of stuck on with this problem. Because I don't really know how you show that for an arbitrary dimensional matrix. And there is something called Sylvester's criterion. But it makes me, but it doesn't meet Sylvester's criterion, I don't think. And it makes me think that I'm getting saddle, that this is a saddle point, and either that's wrong or it's surprising. Well, either way, it's surprising, but it could be surprising because it's wrong. So in class just a few hours ago, we were told the intended way of doing this was to use Lagrange multipliers. And so that's what I wanted to back up and try and do. So the function that I want to optimize this time we'll have n many dimensions, not n minus 1. There's a different thing in class. I might try it both ways, because there's 2 different ways we could represent this function. It should come out to be the same. I hope it would. I'm going to use this, though. Oh! Too early. And the constraint we are optimizing it under is P1 plus P2 plus P3 Pn is equal to 1. And all of these P sub i's are between 0 and 1. I don't know if that part is going to be important, though. I mean, it's good to keep in mind. So for Lagrange multipliers, we take gradient f equal to lambda gradient g. And we get a system of equations with this plus that. So let's try doing that. So gradient f, the derivative with respect to p1. Oh, I mean, I did that before. Is that? No, it's not high school math. I'm happy to talk about high school math, but right now I'm just working on, like, my grad school homework until someone asks me a question. Okay, with respect to P1, with respect to P2. Was a joke? I don't get it, but okay. Is equal to lambda. I guess all these are just 1. I think I'm supposed to do it the other way. I'm sorry to hear that, Yug. Oh, Math Pond, thank you very much for the raid. I hope your stream was good. Puzzlandy, hey, welcome in. I've seen you around. I promise I'll catch one of your streams one of these days. But I hope it went well. For anyone here on my end, please do check out Math Pond. What were you working on? Right now I'm just doing a problem for my math biology class about it's called population genetics, like, broadly. This particular problem, I'm basically trying to use Lagrange multipliers to find the maximum of an n-dimensional function, which is kind of tricky. I initially did it a different way, and then I got kind of stuck, and we are given a hint in class to use Lagrange multipliers instead. So I'm trying to work that part out. Hey, yo, algebra done nasty. Oh, wait, yeah, okay, this might be way easier if I do a different thing. There's different ways I could represent this function, and I think the other representation is way easier. P... Ooh, well, no. I equals 1 to n. I appreciate the follow anyway, thank you. Just believe it, water and oil cannot be mixed. What a crappy fortune. But yeah, so I'm a master's student. I'm going for a master's in applied math. And so for these streams, I just kind of like work on homework or study something from class until someone asks a question, and then I get distracted and go on tangents and stuff. So instead of adding up the number of heterozygotes, which is the thing we're interested in, we can do 1 minus the number of homozygotes. And the advantage of that is that these have a simpler representation, which is, I don't know how to write words. 1 minus p1 squared plus p2 squared plus ... plus pn squared. No, I did not make the AI songs in pen stream. Oh wow, thank you for the 20 street cracks. I think to my if I remember right, Pen Center made all those, but he took suggestions from chat. I want to say there were a lot of people who like contributed ideas. I remember there was one made for me because I look like a character in Ocarina of Time. And Pen Center had it make a song about that character like being me. Oh, I don't think it was me. I would bet it's like Enigma or someone, but I don't remember. Yeah. Okay, so that's gonna change our gradient. It's gonna make it a lot simpler, thankfully. Minus 2p1 minus 2p2 dot 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 minus 2pn. He was chilling on the roof, with the amazing like rainbow pants. And what do we get here? I guess we do we want to get, okay, so we know that lambda equals minus 2p1 equals minus 2p2 equals minus 2, well, let's do our dot dot dots, 2pn from these equations. So if we plug it in this equation, is this going to turn out right? This p1 is minus 1/2 lambda. That p2 is minus 1/2 lambda. Minus 1/2 lambda equals 1. We know there's n many of these things, so minus n over 2 lambda. This is bad. Well, it might be good. Lambda is minus 2 over n. So if lambda is minus 2 over n, oh yeah, Ocarina of Time. Hey, listen. Minus 2 over n equals minus 2p1. Oh, this is perfect. Okay. P1 is, that is so much easier. Oh my god. This is way easier than what I did before. Because I originally took n minus 1 many partial derivatives because I used a trick to reduce one of the variables. And then I made an n minus 1 by n minus 1, or an n minus 1 many systems of equations. And I solved it. I got the same result, but it was really hard. Because I ended up like having to find a series and figure out it's a closed form for its sum. Okay. Actually, we don't have to say P1. We can say P sub I. Okay. Now, is there, when we're using Lagrange multipliers, is there a nice way of classifying this critical point? Because that was my issue with my other technique too. I couldn't really prove it's a maximum. Plug them into the function. Well, don't we need to plug in neighboring? I mean, I guess, okay. There's only one critical point. So I guess we could find the value at the critical point and then find any other value. And as long as it's less, I think we're okay. Well, how do we know it's not a saddle point? Because of the extreme value theorem? I guess because of the extreme value theorem. Yeah, ooh, that's true. I never used the extreme value theorem in multivariable though. I don't. I guess we could parameterize it. Maybe. I don't know. That's a problem for future me. Let's at least start by checking some values at least, like manually. Or at least like what we want to do is check. I just want the value f1 over n, 1 over n, dot dot dot, 1 over n. 1 minus 1 over n squared plus 1 over n squared. 1 over n squared. We have n many of them. 1 minus n over n squared, which is 1 minus 1 over n. Well, that's kind of funny. As n gets large, it's getting closer to 1. It's basically, I guess you could call it a plane, a hyperplane. Because these are all proportions, so they have to add up to 1. I mean, I could maybe like, it's not. It's not very like mathematical, I guess. I mean, it kind of is, but like I can make like kind of an intuitive argument where if we're at the edge of the domain, that necessarily means that some of these proportions are 0. And that's not very interesting because it means we don't truly have as many alleles. And we know that this 1 over n must be a maximum or a minimum. Like, I mean, I don't know if I buy what I just. I don't know if I buy the argument that I said. Hmm. So like, I don't know. This is a tricky one. In 3 dimensions, the domain is basically the part of a plane in the first octant. Like it will be that like triangle. Hmm. I wonder if we have to parameterize each of the boundaries individually. Well, the thing that parameterizes them is taking one of them equal to 0. So maybe that's not so bad. Zach, hello, hello. What is the value of factorial? I mean, the self-deprecating part of me wants to say 0. I don't know though. I think there's a more clever answer there. It's a joke. Infinite. It oscillates depending on my mood. Also, the punctuation of that question is kind of funny. Like like that it makes you think of like the what's that called? The interrobang, the question mark exclamation point. Is question mark commutative with exclamation point? Question mark. Um, I guess we have to say the operation first. I mean, do we? I guess if we're maybe not. You know, I'm gonna pass that off to an algebraist. I'm gonna find one and ask them that question. You know, I feel like Gödel could actually answer that question too. About, well, I mean, he can't now, but he could. um. Okay, so checking values on boundaries. Staying awake, staying awake. So if one of these is 0, all the other ones must be n-1? Question mark? So that they add up to 1? Does that make sense? Yes, because we have n-1 many of these things. So you add them all up. Okay, good. Oh, 0. Does that make sense? Wait, I'm not squaring them. That's the issue. It doesn't make sense. You know what? Just get out of my life, actually. I'm gonna rewrite you. Formality question? Sure. Okay, and then we have n-1 many of those bad boys. Okay, and how does this number compare with that number? Hopefully this one is smaller. 1 over n minus 1 is a bigger number than 1 over n. So 1 minus a bigger number is a smaller number. Okay. Hell yeah. Wait. The alligator eats the bigger one. Okay. I think this is good. I think I figured out the problem now. Or like I've solved it. It is kind of a shame. I already latexed up this n minus 1 system of equations. I'm kind of tempted to just put it as an appendix to my homework because it's already here. Like I already made it. And it'd be a shame to just delete all this work. So just like trig functions, is there any way it could be interesting to make a bigger Lambert W function? Lambert W, right? What do you mean bigger? And like, what's the name of a trig function that you make bigger? Clonk. Great works are performed not by strength, but by perseverance. That's a great fortune. That's one of the best fortunes, I think. I like that one. Okay, so when you're talking about trig functions, you mean like going from sine of x to like a sine bx plus c plus d, like this sort of thing? Yes? Okay. I guess we would call this maybe like generalize. Like generalized Lambert W. I mean, it must be difficult to learn math in not English and then try to talk about it in English. So and so you're proposing to, because there's different ways that you can generalize things, and so this is one way you could. I need to look at the Wikipedia page. For b less than 1 over e, function has two things, like two chords. Yeah, like branches. Is what we would call those. Like, so I know you can't express the Lambert W function like cleanly, but like I don't really know where to start with it. Hmm. Why is this true? If x is real, for minus 1 over e is less than or equal to x. Um, 0 less than x is less than 1 over e? Is that what they said? Oh, minus 1 over e. I never had to use it, but I've seen it get used. I don't really know that much about it, to be honest. This is a funny looking function. I guess I can see it. So like we have a vertical line issue here. How do we like show that? I guess you can still take derivatives of this, right? Just be implicit. How do you, I don't know how you take the inverse. I thought the point was like you couldn't. Hmm. Wait, what W are they? I don't know what year this was written in. Oh, wait. Well, I'm like, well, what year was this written in? They're talking about George W. Bush? Oh, this is written in 2005. Oh my god. It's like a walk in the park. Hey, energy. Hmm. Okay, I like that this author. I always thought that W was like the laziest letter of the alphabet because it's literally just a doubled U, and like this author is calling that out. U is the laziest because it copied. No, you didn't copy W. There's no way. Am I actually the author? Yeah, Casey. You caught me. I wrote this when I was I can do math. 8 years old. I is the laziest. It is just a line. But also there's a joke in there too. I is the laziest. Hope you're doing well, walking sick library. Um Hey color cone. Um this is like they get this curve numerically though. I don't feel like I understand this the Lambert W function. So the thing we're talking about right now is Lucas was asking, and he came up with this kind of like generalized Lambert W function. Um, and I was trying to understand the Lambert W function in the first place. So I haven't really like messed with it, and I'm kind of struggling even with that. um, but yeah, so I'm not sure what to say about this yet. Why it is or it. I mean, you can always define a function like this if you want, but like your question was, can you do anything interesting with it? And that's always like the hard question. I'm not feeling this music right now. We make it slightly different electric music or electronic music. Um, and then energy, you're asking about the wave equation, Schrodinger's wave equation. I don't think I know enough about it. Hmm. Yeah, I don't know enough about where this comes from. I don't know really anything about the physics of this. I've messed around with it a tiny bit, just like in the way that mathematicians do, and just ignoring what things actually mean and just trying to solve the equation. But I don't know anything about the physics of this, unfortunately. But that generalized form solves like 15% more equations. That's what I like about math. It's a little more creative than physics. I mean, I think physics can be creative too. This is the heat equation with an inhomogeneous term. Well, the imaginary coefficient is a little bit weird also. But yeah, unfortunately, energy, I don't know enough about this to speak on it. Um, I did just recently watch a Veritasium video that talks about like the history surrounding this type of thing, but he doesn't really explain the equation itself, unfortunately. So I don't think that's gonna be that helpful to you. Yeah, I'm not sure where I can point you towards energy. I'm sorry. There probably is some good video on it on YouTube, but I haven't seen one. What does the IMO have in touch with us? It is kind of weird that it's not a wave equation, but it describes like these waves, I guess, kind of. I don't know. First, you need a Hamiltonian, which depends on your system, just like in classical mechanics. I already forgot what that was in reference to. Color cone. Sorry. So it looks I can keep kind of floundering with the Lambert W function, but I'm not sure. It's more like Newton equation. The equation changes a lot depending on your system. Oh, okay, yeah, for Schrodinger's equation. Yeah, that V of xt is like, it can be a lot of things. I remember I wanted to ask you something, color cone. H equals K plus U. Right, yes. Okay, I remember that. Or no, I've seen the Lagrangian. But that makes sense about the Hamiltonian. So it's not relevant anymore. Like, I found a different way to go about this problem. But for this problem that was for my math biology class, I basically ended up with this, we can call it an n by n matrix. And I was trying to prove if this thing is negative definite. And that was hard to do for n dimensions for me. This is basically like it's a Hessian matrix, and unless I made a mistake somewhere earlier in the problem, I think it is supposed to be negative definite, which would mean that the critical point I found is a maximum. But yeah, I don't know if you knew of a theorem that might like help with that. I saw Sylvester's criterion. But I think it didn't meet Sylvester's criterion, which makes me think that I might have made a mistake. Gonna go now? Sounds good, Lucas. I honestly, I'm not sure that I can. I feel like I'm not really getting the Lambert W function in the first place. I'm sorry. There's a criterion that reduces to checking a very small. Good night. Really? So for Sylvester's criterion, yeah, n is arbitrary. I was assuming that -1 times a positive definite matrix is negative definite, so that this theorem would apply, but the problem is that I was getting determinants with like alternating signs, so how is the matrix defined? -4s on the diagonal and -2s everywhere else. Oh, okay. No worries. Tofu's important. Okay, we can try a little bit more with Lambert W function while we wait for color cone. Hey, Papadoria. Yeah, Lucas left, but he was asking if we can do something interesting with like his idea for a generalized Lambert W function. And I was trying to think of something, but I don't really understand the regular Lambert W function in the first place, and so I really don't know what to do with this generalized thing that he suggested. Oh yeah, no worries. Take care of your food. So yeah, the matrix is arbitrary dimension, which was the thing I was struggling with. -4s on the diagonal, -2s everywhere else. Hey, Ayush. And so it's okay if not, like, because like I said, this problem, like it's ended up not being important, so I did it with another way anyway. But I was kind of curious if there is if you have an idea of something to do with this. But don't like stress over it. Lambert W functions are just the inverse of x e to the x. I think there is some way we can compose with other functions. Yeah, I guess Lucas was trying to figure out like what type of problems it might be useful for. And yeah, I don't know what just like the regular Lambert W function is really useful for in the first place. So 2 to the x plus x equals 5. Okay. Oh, this is kind of crazy. Delay differential equations. Hmm. It's rarely used, but it's just helpful when we have an x in the exponent and also a polynomial. X squared plus 2 to the x equals 5. Okay. Fair enough. Okay, so I think I solved this biology problem. It'd be cool to figure this thing out with the n by n matrix, but it's also not that important. And now there's two options for what I can do. I can work on messing around with little o and big O stuff again. Or I can work on scientific computing stuff. Like coding up some like basically we're learning about like denoising data. I think you reduce, check the principal minor, and do it by induction. Oh, interesting. Because I showed earlier that it should be like a full rank matrix, so it shouldn't be 0, or it should never be 0. What is the principal minor? Like, is that like the 2x2 matrix up here? You will enjoy razor sharp spiritual vision today. That sounds like a superpower, Clonk. Bigger square starting from the top left corner. Interesting. Yeah, like the first one is -4, but that's like trivial. And so maybe you would want to start with like a 3x3 or something, just to make sure you're not trivial. I guess it's probably worth checking this in Wolfram Alpha, what these determinants are. -12. So I would be in trouble. If this next one turned out to be positive, and I'm afraid it would be, which means that I just kind of straight up did something wrong, I think, at some point. Oh, that is a negative. It cannot? Okay. Let me do one more, because I still don't quite believe it. And I'll read that in a second. Papadorius / Piggy Master. Because for 2x2, it's positive. Unless I did something terribly wrong. Well, it is negative. Okay, yeah, it's positive for 2x2 only. That's what I don't like, I guess. Wait, okay, yeah, never mind. You always found it very funny, like imagining you're solving something, you find out you can't. What is the next step? To just call the answer a new special function. It's more prominent with non-elementary integrals, like the li function. Oh, yeah, or irf. You're just not... Yeah, those are kind of weird. That like we sometimes like it comes up all the time, but we don't know how to solve it, so we just like give it a name. Okay, I did spend a lot of time looking at this Wikipedia page last night. I was getting confused on this notation though. Its leading principal minors are all positive. This one here. I guess it is, yeah. That's so weird though. I like I don't think I made a mistake. But it seems like it's just not negative definite, yeah. Hmm. Yeah, check your tofu. If I did this the other way, huh. Okay, you know what? What if I use this definition for f instead to construct my Hessian matrix? So the second derivative in P1 is -2. We're gonna have -2's on the diagonal instead. Okay, I was just trying to construct this Hessian in an alternate way to see if it comes out to be something similar. Because there's two different functions that I could use that should be equivalent for this problem. And I just want to see how the matrices would compare. So, okay, the diagonal is just -2. Everywhere else, like, is it going to be zeros? I think it's going to be zeros. This comes from my math biology class. PII is, it's the proportion of people, like the frequency of people, with two alleles for the same gene. It's a little bit hard to like describe, but basically every person has either like P11 or P12 or P22 or like any combination of two numbers up to n. Like, I don't know, n -1 or something. And so capital P is related to small p if it's PII it's equal to small p I squared, and if pij, for if they're not equal, is 2pi pj. And so since these are proportions, all of these have to sum up to 1. Yeah. And so we're asking about the proportion of people who are like IJs, basically. And so I was using this definition to construct the just barely muted in time for that sneeze. I did use this definition originally to construct basically an I made an n-1 dimensional function instead of n because of a trick. And so I got this complicated thing. And so I was making a Hessian with that, which is where I got my matrix with fours, negative fours on the diagonal. But I think it's way easier if you use the other definition and just do 1 minus that. Or at least theoretically it would be. I think these are all zeros. But the issue is that this isn't the sign of the determinant is going to alternate, so that's not good either. A maximum should be at the point 1 over n, 1 over n, 1 over n. And so I was trying to use the Hessian to prove that it's a maximum, but that's the part that's not working out. Yeah, no, it just kind of seems like an interesting like linear algebra / multivariable calculus kind of question. Oh, wait, yeah. So there is a problem with what I just wrote here. Yes, you're right. Oh yeah. So yeah, this is I was taking this constraint into account by just plugging it in for Pn. That was the trick that I was doing. I don't know if that's technically right, but yeah. And so the Lagrange multiplier is the easy way. I did that down here. But before I realized Lagrange multipliers are what you're supposed to use, because we were told to use this in class just today, but I had already worked on the problem when I did all of this mess with solving an n-1 dimensional system of equations. But yeah. So that's why I said, like, it's not important. Like, I already have an answer that works. I was just like, I was just curious if you had a thought on like how I could make that work, but the matrix might just be wrong. So. I probably should just drop this. Community 2 by 2 minors shows positive. Yeah. Yeah. You got me. I know. I was just like, I felt really proud when I was doing this last night that I actually solved this really disgusting system of equations, because it involved finding a telescoping series and getting a formula for its sum. And I actually got the right answer out of it. But then when it came time to prove that it's a maximum, it didn't work. So okay, that's fair. That means I probably, all right, I definitely need to edit my work for n equals 3. Because they made us do it for small cases first before doing it for the arbitrary case. It's annoying because like I already latexed all this up because I didn't have a better idea. So like, yeah, okay, may as well like turn this in because it's something. Uh, but it is just kind of wrong, I guess. Oh well. Okay. The maximum principle for the heat equation special? I don't think I've heard of that. It'd be somewhere on the Wikipedia page. The maximum function on a domain is the same as the maximum on the boundary. Hey, Desson. That, like, after a long enough time? But you can have, like if it starts out with a bump, the bump will flatten out. But, like, I guess like if just like one dimensional, you can have a starting condition like that, and like the maximum's right here. That's different from the. Hey Reaper, hope you're doing well. Yonetta, you too. Yeah, we're heat equating. I guess that's just what your sub badge happens. Oh, that's my 1 year sub badge. Wow. Oh, okay. I guess I should be. Heat balls? No, I'm not. Okay, so if I start with a Gaussian bump, it's going to get smaller and smaller as time goes on. I guess I'm taking Dirichlet initial or boundary conditions here. The maximum on that domain is reached on the boundary of the domain. I mean, I'm saying like the thing that I don't get about this is the function, or is the maximum like it's just right there. It's not on the boundary at all. On T0. Because like we're saying that T equals 0 is a boundary. Like this also counts. I guess so. Oh. Huh. Okay. So okay, that makes sense. Yeah, because this describes how heat dissipates. It's never going to like if this wasn't true, it would mean that heat is flowing from cold to hot, and it definitely does not do that. Okay, that makes sense now. Thank you. The mean value property holds quite directly for harmonic functions, right? Um, but to make it work for solutions of the heat equation, you need to define a heat ball. Interesting. Me, I'm gonna hide my screen. I'm gonna Google heat balls and see what comes up. Did I mean heat boils? Oh God, I'm seeing actual boils like on your skin. Heat balls math. Assume some bound on your solution. This gives you unicity to the heat equation. Hmm. Here we go. We got heat balls. A super level set of the fundamental solution of the... Oh God. Yeah, I don't know what this means. Diameter of the heat ball is little o of 1. It sure is. As lambda goes to infinity. No clue. You're taking Algebra Qual tomorrow? All I learned was a few tricks for major C's exercises and techniques to prove groups are not simple. Good frickin' luck, Dustin. Hope you do well. Okay, I'm debating what I want to do now. I mean, we really have not done much physics, I would say. I mean, like, aside from solving PDEs is the only physics that we've done. But I enjoy it. I mean, the heat equation goes both ways in my mind, at least. Yeah, I mean, I would want at least a like I wanted a good dose of physics in my applied math. I do want to show off this one homework assignment because I think it's actually really fun. This is for my scientific computing with the data class, and we're learning how to like denoise data. And this homework assignment is like, I think it's like generated data, like it's not real data, but like, we're trying to like figure out the path of a submarine, and we have acoustic data that was obtained in like half-hour intervals over 24 hours. And we have to figure out how to like denoise it and get a rough idea of the path of the submarine. And I haven't really made much progress on this yet, but I think it's a really cool assignment. And there is something that I could play around with. I just need to open up my Visual Studio. How do people do that? Denoise data? We can talk about it. I should have a good sample that I can show here. Yeah, that's it. Okay. Some model the heat equation with finite propagation speed. Oh, that is a problem with the heat equation, right? I bet someone's tried to do that. Okay, so this is like a sample for denoising data. So you don't understand the heat equation? What about it? Oh wait, is your how do people do that about denoising data or about either way? I'm gonna explain this. So we have just like a sample function just to have perfect information about the thing that we're going to denoise. So this is apparently called a chirp. You have this kind of like cosine at one frequency that is being multiplied by a Gaussian bump, so it only matters around 0. And it's kind of steady state sine wave with its own frequency k2. And if you graph that, it looks like this, where, well, I guess there's an offset, but like in the middle, the cosine wave is the important one, and then off to the sides, the sine wave is the important one. And we're going to take this function and add noise to it, so we can test our denoising idea. Wait, where do they add noise? Is this in the next one? Oh yeah, here we go. Okay. So again, the original F, and then we've manually added our own noise to it here. And let me catch the chat. Bigfoot Smallhead. A little bit. I haven't made an actual like app before, but I can like solve math problems with code, I would say. Essentially you want a solution ut equals slash delta u, then PD is keep at it ad infinitum. I mean, I assume Destin knows what the heat equation looks like, but I assume there's a deeper question that Destin doesn't understand. Python. Welcome in. And so yeah, if we have this noisy data, we can recover something like the original function. Thanks for the follow. We can recover something like the original if we take the Fourier transform of this noisy data, because the noise is at a different frequency than the frequency of the waves that we actually want. So if you take the Fourier transform and graph the magnitude of each of the frequencies, you get something that looks like this. And so this is like an ideal case where the frequencies we do want are these like clearly these 4 peaks here in the middle, and then the noise is just kind of all the stuff on the edges. So what we can do is take a filter that's this function over here, and close to 0 it's equal to 1, so it'll hardly touch anything in the middle here, and then it trails off as we get into the higher frequencies. And so it's going to basically drastically reduce everything on either side of this while maintaining more or less the stuff in the middle, and that's what we want. So you literally take these two things and multiply them. And then you do the inverse transform to bring it back to the original like wave, and this is the denoised version, and it's pretty dang close to the original. How does the Laplacian work with respect to u geometrically? I think of it in terms of like concavity, where the Laplacian is just basically your second derivative in multiple variables. And when things are concave down, it means you have a maximum. Let me just like draw this. At a given point in time, let's just say t equals 0 is this slice that we're looking at here, and we have our Gaussian bump, because why not? Like right at this point here, or like even anywhere along it too, but just like focusing just on that for the sake of simplicity, the second derivative is going to be negative because it's at a maximum. And so in time, at this point, u is going to be going downwards because it's concave down. And it gets flipped if you have a minimum, because now your concavity is positive, so u is going to be going up. So it tends to like flatten things out. That's how I think about the Laplacian, at least. You're back with your tacos? Ooh, you made tofu tacos? Tofu tacos? Tofu tacos. That's tofu taco, tofu taco, tofu. It's not hard to say. But yeah, so that's at least how I think of the heat equation. Like, in another PDEs, whenever you see Laplacian, it's going to mean that the function is dissipating in some way. And like it's kind of like, I think it was like losing energy, I guess. I don't know if that's like the right interpretation, but that's how I think of it. Maybe losing energy is probably wrong. Just spreading out the energy. Yeah, I got that from a 3 blue 1 brown video because he has a whole video on the heat equation, and you can actually show a nice relationship between second derivatives and averages, where like if you kind of track a single point, the second derivative is approximately giving you an average of the points around it. So like this point becomes the average of these 2 points. I forget exactly how we did that, but if you like make it discrete instead of continuous, you can do that. It's crazy how people found ways to use the heat equation to prove hard theorems. Did they? It kind of measures the spreading of a form then? That's how I think, but yeah, like spreading out whatever thing it is that you're measuring. FA! Rubik's Cube, we can do that. Illustration project in my topology class. Really? Interesting. Hope you've had a good day, FA? Why is my hair like that? Man, I really want a haircut, and the place where I was going to go for a haircut, the barber is on vacation for like a month, and I was looking for other places instead, but the first like 3 or 4 barbershops I found charge minimum like $60 for a haircut, and I just want to buzz this crap off now after seeing that. Okay, let's scramble it. Ooh. Left, down, left 2, U2, R2, 2, down, L2, F2, U, F2, U2. I think back is like that. Back prime. That's back, I think. F, U, L. Okay. Now I'm gonna inspect it. Wait, why isn't it working? Dang it, I keep knocking over my pen. You're wrong, FA. There we go. Now I inspect it. I can't find the pieces that I want. J-perm? Do you like J-perms? No, okay. Not my best time, but not my worst. Thanks for the redeem. Never have ever solved one in my life. The only reason I know how to solve one is because I was very bored in high school and my friends were doing it. And I just wanted something to do during class. And so like teachers would call me out. Like, so I'd just be in class just like messing with my cube underneath my desk. And teachers would call me out and tell me to stop texting. Like they think I like, you know, am popular like that. And I would just hold up my Rubik's Cube. And then they would shut up, and I would go back to playing with my Rubik's Cube. Oh, another one. Okay. Let me catch up with the chat first. My My advisor told me he would gift me a notebook just so I could practice drawing pictures since nothing I write has pictures. Pictures are great, though. My hair was touching my shoulders until today. Now it's around size 4. Ooh, that's a big change. You probably feel lighter, like your head feels lighter. When dealing with holomorphic object in geometry, we must always use harmonic functions. Laplacian is an elliptic operator, so you can apply all the fancy functional analysis, show a bunch of theorems like finitude. Oh, yep, those are definitely words. Okay, scramble it. Honestly, and solving a Rubik's Cube is just memorization. There's no real, like, skill to it. I'm also, like, washed up it. I used to be way faster. Alright, scrambled. Let's inspect it. This is annoying. Ah! Oh, my fingers are cold. Ah, my fingers. Why aren't my fingers cold on the last one? Ooh, I actually got that G perm. Jeez. Yeah, the one that I will not do a redeem for is my 7x7. This one takes too long, but I also have this one just sitting on my desk when I'm watching like a stream or a show or something. He once Googled homology and found out the hard way Google prefers biology over math? Well, now I have to Google it. Oh, okay. I thought you were going somewhere dirty with this, but no. Okay, it is just an actual biology term. I just Googled... No, just the other day I Googled... You know what? I'll just Google it. I Googled Jordan region, and guess what came up? The country of Jordan, of course. Why wouldn't it? Then I had to add on math. It looks like guessing curvature was the early beginnings of this, since small circle was used to define its curvature. Huh. Yeah. No worries, Yonetta. Okay, this one math word in Portuguese that shows a bunch of jack dudes if you Google it. Really? That's funny. I remember at work, back I was even just an intern. This was at a job I had during college or university. A coworker was telling me about empanadas, and I went to Google Images and looked for empanadas on the work computer, and for whatever reason, a bunch of like women bending over showed up, and I don't know. Apparently, it's also a dirty word or something. I closed right out of it, and I was wondering if I would get in trouble for it or something, but thankfully it didn't. What's your favorite tool? Not theorem, lemma, prop, and complex. Ooh. For you, it's the parameterized arc. Favorite tool? Not theorem, lemma, or prop. I mean... Does, like, Fourier transform count? I guess I would do that. There is like a Fourier's theorem or whatever, but yeah, I feel like saying residue calc is basically saying a theorem though. I don't know. Depends how we're counting them. Um, hmm. So I guess in this homework we do need to do filtering, but we also need to do a different, like the filtering that I just like talked about before. But we also they mentioned we also have to do an idea with averaging things, and I want to figure out like what that would look like. The Portuguese word is vibrado, which I'm probably saying wrong. Which is how we say fiber bundle. Oh, and that's what shows you a bunch of jack dudes. That's funny. I feel like I need to give this equation a time dependence to make this work. Such a good line from Barry. Quitter, thank you so much for the prime, dude. I hope you're doing good. Oh, I can kind of see that, I guess. For like a fiber bundle if you're jacked. 5 months. Thank you, thank you. Am I a fiber bundle? No. I cannot stand the gym. I get really annoyed at other people. Well, okay, I get really annoyed at people not following etiquette, but I also get annoyed at people who are following etiquette and are just existing. But I don't want them to be in the gym. Like I want to have the gym to myself. So I usually end up leaving the gym feeling really annoyed that other people exist. Yeah, I figured it was body fat. um hmm. I don't know how I don't know how I should make a wave look though. I wonder if the textbook has a good example of this. Yeah, that's my problem, Color Cone. When I go to the gym, there's just too many girls who want my number, and it just like I appreciate it, but it takes a lot of time away from my actual like workout. Playing Tarkov, hell yeah. Couple of dumbbells at home. Start calling them a home gym. There you go. That works. It's actually pretty close to 50-50, Dessen. I was kind of surprised. Oh yeah, I think we're gonna do principal component analysis maybe at some point. He once got 6 numbers. One more would be a full telephone number. Yeah, I remember that. Okay, so right now I'm just looking for a good example of like a multivariable wave function. Can't divide by 0. How do you actually integrate those integrals? Wait, was I showing an integral? Oh, like this one? Sine mx cosine nx? Oh, I mean, an integral like that, you just use a trig identity. Like one of these bad boys in the lower right. And yeah, as Piggy Master said, like if you integrate it over a period, it's gonna be 0 probably. I can't find where this textbook actually says. I'm sure it does that. Oh yeah, here. Yeah, this is like the entire thing that makes the Fourier transform work. Or the Fourier series work, maybe. I mean, what if that means that your class has infinitely many girls, though, if you divide by 0? Actually, no, it means the ratio is infinity. Never mind. That doesn't work. I don't know how math works. But yeah, you can just use identities to do these. It's not that bad. We did it in Zach's series class. Sine space nx. Oh, I do hate that. I don't know why you would say that's based. That's terrible, I think. Phobos, hello. Hope you're doing good. Yeah, trig identities are kind of the worst. I'm trying to figure out stuff with denoising data. So we're like we took an example of a wave that we do know, added noise to it. And then this example file takes a Gaussian filter with the Fourier transform, and it denoises it. So, like, this is the original noisy. Is my cursor showing up? Oh, I don't think it was. Oops. Original, noisy, and then the cleaned up one. I'm trying to look into. I'm trying to figure out a different denoising technique, though, that the homework assignment mentions we should do, but we don't have an example for, at least not yet. But I think I can figure it out on my own. I think it's when you have multiple sets of data over time. I think you can average the samples over time, and if the noise is mean 0, it'll eventually cancel out if you average it enough times. And I'm trying to search for a good example wave function to test that with. This part honestly amazes me about Fourier transforms, gives a reason. Oh my god. The Fallout New Vegas alert. Yonetta, thank you so much for gifting Color Cone a sub. Holy crap. I really appreciate it, dude. Also, I just, that reminds me, I did get through, actually, I think there's a new episode today, but the season 2 of the Fallout show, and it's really good. Okay, yeah, this part honestly makes me about Fourier transforms. It gives a reason why we don't have a logarithmic transform, like some of tangents, or some of gamma functions. Oh no, that would be terrible. Yeah, that is a cool point though. Like why sines and cosines work, but not necessarily other functions. The plural of basis, you got it right. Bases, B-A-S-E-S. I will sub to your channel if you can compute that limit in your Discord general using L'Hopital rule. Well, I guess you already got subbed. Okay, so that was the joke that I missed. Let's see what the limit is though. Wait, wasn't this posted earlier or something? This looks kind of familiar. Using L'Hopitals? This doesn't look... Maybe it is bad, but... Actually, it probably is terrible. What am I saying? Which areas do you think is where most female mathematicians go? At my university, most are discrete math and geometric analysis / topology. I mean, I don't know enough to really say that. They're kind of all over the place because it is just like 50-50 to start with, more or less. I would guess that there's less in the AI part of applied math and more in like the biology part of applied math. But I don't have much to really base that on. You optimize the problem, made a computation unnecessary. There you go, Yonetta. Didn't your class actually read every single word of the book? I don't. I doubt it. Anyone does. Well, hospitalizer? I like that name for it. Might make it worse, maybe. Be more effective to denoise if you use some type of flower-like function instead of trig functions. Maybe? It's not that important, I guess, what it is, but I did want something that's completely unrealistic. Telescoping something to this limit, I feel like I've seen this before. I do feel like I've seen this before also. So the task from Collar Cone, if I choose to accept it, is specifically using L'Hopitals. Let's try a round of L'Hopitals, I guess. How bad could it be? Famous last words. Should we verify? I'm not going to verify that L'Hopital's works. I'm just going to assume it works. Wait, x equals 0? Excuse me. Come on, are we animals here? Okay, the derivative sine of tangent. Cosine of tangent times secant squared minus tangent of sine, okay. Secant squared sine cosine. Yeah, is L'Hopital's actually helping us here? Is the derivative of arcsine, is that, it's like 1 over root 1 minus x squared? Field medalist YouTube thumbnail? Oh my god. Paul? Just tell me what I want, Paul. Thank you, Paul. Okay. Okay, so this is our Lopit. Oh, wait. Okay, yes. Trying to figure out a good week quota of problems this year. The problem is that problems are very wildly in difficulty. You don't think you can set a hard quota, maybe a time quota. Ooh, yeah. There you go. So what happens if we try to plug in 0 into this thing? It's a lot to keep track of. Okay, tangent of 0 is 0. Cosine of 0 is 1. Secant of 0 is 1. Sine of 0 is 0. Secant of 0 is 1. Okay, so we get 0 on top. Oh, no. Please be finite on the bottom and not 0. It's gonna be 0. Just watch. This is 1. That's 1. 1. Bruh. How many times do you have to L'Hospitals to make this work? I don't think I'm willing to do it a second time. This is disgusting. 6 or okay, yeah. I give up. You got me. It's not worth a sub. You just never was one to eat my vegetables. You always skip the routine exercises. I think that is a terrible practice. Yeah. I was just thinking about a metaphor like that the other day with math, like with instead I was thinking of like eating. You have to eat your dinner before you eat your dessert, and like spend time on the fundamentals before you should move on to the harder stuff. There's actually a trick to solve it. It makes sense. Wait, what? Ooh, fantastic accent. You wouldn't? I could figure it out, I bet. Yeah, yeah, yeah. Oh, that you notice they're inverses. Speak faster. Wait, there it is. Oh, wow. Why? That's a wild way to do it. Holy crap. You have to know how the functions look around 0, I guess, but like that's a lot of if you're someone who's blind, that's a few leaps of faith that you have to take to get that. Okay, how would I visualize sine of tangent of x? Yeah, switching so it makes people feel stupid. I'm just kind of interested to see if I can intuitively figure this one out. We're gonna have asymptotes, like tangents asymptotes, right? So can we just figure out between minus pi over 2 and pi over 2? And then it's gonna repeat, I think. Oh, wait. Oh, this is gonna be something fucked up. I think close to these, it's gonna be like sine of 1 over x. Like it's gonna be oscillating infinitely, isn't it? You know, okay, never mind. I'm going to Desmos. This is way harder than I thought. I give up. After 10 seconds of thought, that's all I need to give up and use a calculator. Oh, I was right! That's a cool function. I like this one. My suspicious non-verified history tells me there's a point that Vlad is one of the few mathematicians that followed a key, whatever that is, after Grothendieck's passing. Arnold is the one responsible for that sigma physics quote. Yeah, math is your physics where experiments are cheap. We just need f prime 0. Okay. You don't see anything cool about a bad topology? Wow. I'm just talking about aesthetics here. Okay. Honestly, I might wrap up the stream here. I would normally go longer, but I do feel kind of pre-sick and I don't want to press myself. Yeah. There are no bad topologies, like there are no bad questions. I mean, I don't know enough about the topologies to know. I feel like I probably wouldn't like most topologies. Snazzy, thanks for the follow. But yeah, I think that might be it for us for today. I could go into the data analysis stuff. I feel like that's gonna be a whole like other hunt for the Red October. I think I want to take a little break before I do that. So calc-based physics 2 makes my head want to explode. Oh, that sucks, Snazzy. Is that like electricity and magnetism? Because I'm a little bit rusty on it, but I bet you I could help out with that. And then another good person to know. Well, there's a few good people to know. Yeah, sorry, Finlux. I don't have a ton of energy today. Let me actually. Okay, no, I'll give you the full list. So I'm not the only person who does like help on Twitch. I'm sorry, because I'm about to like end my stream now because I'm tired. But out of the list of people that I just said, Actual Education can help you out too. Merriweather Remark, I bet, could help you, and Physics and Depression could help you. Like for sure. And see if you have a question in the future, feel free to like let me know. Sorry you caught me at a bad time. Good luck with your class though. Okay, there are no wrong answers. That's a good Kevin quote too. Sorry, my classes next week, all of them are way beyond my background. I do a few things thanks to self-study. That's good. Red Collar? I mean, I don't think Collar is streaming. YouTube